Xavier, thank you. It was, as always, very interesting. And we have to recognize they have great videos. Later on, you will see one of our videos. We are okay. It's another level of videos, but it's also interesting. I will share. I will take just a few minutes because normally you all want to listen to Ramon and to my specialist in the afternoon, that they will go to the single details, so difficult things and so on. And this time I will be very limited in time because I want to go straight forward. This is the project, and we talk about the digital grid, and I will simply tell you 3 years for doing what. I will try to explain what it's all about and what's next. Because, just to be clear, because they will really go deep in the technical details. So, as a summary, we have consumed 485 person months during 3 years. If you divide, it's equivalent of having 15 highly skilled specialists working only for this project. So it's kind of company. Imagine that you have a research company where you can enjoy of these resources. So the challenge was, at the moment to start, how to more or less design where we wanted to go. So it took me some time watching TED Talks from Steve Jobs and Elon Musk to know how they were behaving, how they were doing. So I learned, and I told them, hey guys, we have an idea. You have 3 years' time. Bring me this. That's easy. But they are so good that they devoted 1 year to make the definitions, to go to all the details. They took another year in the laboratory and a third year to bring something. I'm the coordinator. I'm absolutely happy of the result, which is much more performant, is better. It's really, we got something better than I was expecting. There's only one issue. They came with this. If you remember our first meetings where we were debating on the size was important. And we got this, which is like this. And so engineers, they were really doing a great work, a great job. And because everything which is inside is brand new technologies, new materials, everything is new. So they took the risk of trying new things and putting all together and make it work. So the risk was enhancing. And we were working for this. We wanted risk. We were doing it in Vallfogona and Ripollès because of the difficulties. Instead of making an easy pilot, we went to a difficult pilot because we said if we succeed there, we will succeed anywhere. And we did it. So how is it possible that they came with this instead of the other thing? And we are so happy of our young engineers at CICEA UPC, doctorants and now doctor. He will speak in the afternoon. We were really happy of their work and their involvement and motivation and everything. And they took an advantage of participating in such a project. So how is it possible that they came with this? So it's because of the age. I will speak as your father. I'm not your father. But listen, whenever in life someone is asking for this will not fulfill expectations. So, but we are extremely happy because of being able today to explain a success story. What it's all about is about managing distributed generation. This is difficult for a DSO. Improving the hosting capacity without investments or network reinforcement. Distributed generation will grow, and it will not grow in the city centers. It will grow in rural areas, in the boundaries of the cities. We must be able, with our shape tree networks, to avoid investments and being able to accept as many injection of electricity as possible, creating the Internet of Electricity, reduction of losses due to transmission and distribution. We discovered, in Vallfogona, a lot of things, but one of them was that the watt is a unit still. I mean, the electrical sector is talking about megawatts, gigawatts, and things like this. But in rural areas, watt and kilowatt are still relevant. So things are very close, very easy. So you can properly dimension your generation as far as you are near to the consumption. And consumption in rural areas is really minimum. There's no one single house in Vallfogona with 3 laptops and 2 TVs and everything on always. So, and finally, balancing of phases. So these were the goals, and this is all about. And what's next? Next, we are happy because we have the winter package. Some of you heard about the winter package. This is a geode slide. Thank you for making my life easy. And the winter package is something absolutely great. Unfortunately, lobbies are already working in Brussels, and there's one lobby which doesn't exist, and this is the lobby of the innovative customers, of the active customers. It doesn't exist. They are not able to influence the decisions of the members of the parliament, of the 751 members of the parliament. So the other lobbies, the ones which are really active, they will do their work, their job. And let's see what's out when we receive. But now we have this chapter 3, consumer empowerment and protection. We have here the authority for the data protection. And empowerment. Empowerment is relevant. Article 13 is talking about the aggregator. This aggregator that we all expect is expected in this zoo, in the zoo of the energy. We expect this participant is coming. It's taking too long. Data is absolutely relevant for the consumer. The director was talking about data and the relevancy that it will have in the present, of course in the future, but already now. So we have also the Article 15, active consumers. Member states, they say, should do the necessary things to activate consumers. As we said a few days ago, an active consumer, level 0, is the one which is reading the invoice. So if instead of receiving the invoice and throwing it to the basket, you open it and you read it, you start to be active. So we will go slowly to have a cloud of active customers. Some innovators, some active. It's not needed to have PV cells or micro wind turbines. This is last level. The first one is to be interested in. And finally, we have something great, which is the local energy communities. Local energy communities, it's something that they say it's foreseen to take the place of a distributor where the community, neighborhood, city, I don't care, they are not satisfied with the services provided by the local distributor. So they can, in the text, it's very clear, said that there's a negotiation between the local community, energy community, and the distributor, which is next in the neighborhood, providing with electricity they can manage, they can sell, they can be active in the market, so as a retailer. So a local energy community has more rights, according to the current description, than a DSO or than a retailer. It's accumulating a lot of power. So we will see what will happen in the coming 1.5 years, how the transcriptions to the national regulations will be. But if it's not going to happen in a few years, it will happen in the next wave. So take into consideration that the winter package was, before we had a summer package. And the winter package, in many senses, is saying, hey guys, I'm afraid that you didn't understand the summer package. We will repeat with more details some of the things that we already said. So if it doesn't go ahead and there are changes, in 3 years' time we will have again the same thing. And if you visit the States, they are already there. So the winter package, the only thing it's trying to do is to put Europe at the state of the art, which is already in some other parts of the world. So it's something which is interesting, and this is the future, and this is coming. So Smart Rural Grid is the technology for the local energy communities, for the physical management of the local energy communities. Now, a video. So thank you. It was not that bad. Huh? Yeah, that's it. And now we are some minutes ahead of schedule. That's quite strange. So Ramon, you will have plenty of time for your presentation until lunchtime, the best time of the day, where we expect you to network with all the people which are around. Thank you, Ramon.
Thank you, Santi. Good morning. Let me start my presentation having a quick pictures about history. If you remember, in the 1752, Benjamin Franklin discovered that the electricity as a fluid in the matter. 70 years after, Hans Christian Ørsted discovered that the influence between current and magnetic fields. That's nothing happens when current through against the cable. 11 years after, Faraday discovered the production of the electricity using magnetic fields. And George Ohms explained the relation between resistance, voltage, and current. Why? Why this forest light? Because these personalities, they are people that after another personalities improve this knowledge. Because we are talking with Gauss, with Maxwell laws, we are talking Tesla, Edison, but years ago, thanks this knowledge, they can improve. To be honest, our point of view that smart rural grid is the baseline to get something new, because smart grid, we achieve the real flexibility in a smart grid. In this case, rural grid, but it's scalable in any kind of grids. I'm sure years ago, not more 10 years, this achievement in this project will be the baseline to create a huge level of the smart grid. What is the agenda that I would like to share with you? We explained the rural areas before smart rural grid. We would like to introduce a few words from what is quasi-grid concept. It's an invented word from the project. The dynamic microgrid, what means using electrical network from DSO managing electricity, and also the small scale of the storage. Why? This is three keys that is very important. That the outcome is achieve the rural areas after smart rural grid that it's still working nowadays. And of course, the final outcomes that we achieved till now. Rural areas before smart rural grid is black and white, is iron, cables, poles, all static, and the current is going following, let me say, the gravitational laws, from the more voltage to the less voltage. For more than 100 years, we, DSOs, we are using the same criteria to manage the electrical grid. If we need to increase the loads, we will need to increase the transformer, the capacity of the transformer, the section of the cables, but always following the same criteria. In this slide is medium voltage grid. You can realize that we have a difficult environment to achieve communications. All electrical infrastructure is, again, the countryside is aggressive with the environmental. And the traditional issues from DSO was buildings, old buildings, because years ago all the electrical grid is overhead infrastructures. We have secondary substation on pole and the new building, but it's the same old buildings. And inside we have medium voltage cells, we have transformer cables, low voltage cabinets. That means things without anything important. The same in the pole. We have transformer, we have switchgear, fuses, but it's static and not intelligent things. And the new building is a little bit new, but in the same criteria in the last 20 years. It's not improving and giving intelligence. Let me say that intelligence don't mean automation. This is something different. Okay, and the rural areas, another problem is when we have problems, the difficulties to arrive, because trees cut, the bands, we have difficulty to arrive, and the customers usually call the company hours after. For your information, from yesterday, we lose the electricity. Okay, introducing the new concept, the quasi-grid concept is what is the way to use technology, storage, and several things to create We have real network in urban areas. It's very easy if we have a problem here, supply for another path in the same case. But in rural areas, what is the problem if we have electrical problem, electrical failure? We can create a complex axis to build an imaginary network, because it's not easy to create another path cutting trees. Society nowadays is not very welcome. And also the investment is high. The dynamic microgrid, we are sharing the traditional microgrid. We have a point of the common connection. I think this is the meaning. But this is the DSO site. But just we are managing one point from the DSO. And the microgrid is working without any information and exchanging information from the DSO. This is the traditional. And in smart grid, what is new? We have medium voltage, low voltage grid. We introduce renewable sources. We introduce storage in two locations, Les Artigas and Berger. And we create several sectors that we have the capability to manage independent sector and dependent sector. That means this central sector is depending on of this one. If we have problem in the external areas, we are not able to manage this sector. That means we can, after electrical fail, logically, if we are working in a grid-connected mode, we can achieve the maximum improve of the electrical grid. But after programmed works or electrical failures, we can still delivering in the same quality of the electricity at the few customers that they are grid connected. And the dynamic microgrid is the system taking decisions and decide how many customers we can supply after electrical fail, because not always it's needed. We are able to supply electricity at the same level. And as a result of that, we discovered that it's not necessary to install huge capacity of the storage in the secondary substation, because if we are installing huge renewables PVs, for example, huge storage capacity, we are exchanging the point of the zero current, the losses, but the outcome, the final outcome is the same. Studying our case, we discovered that in rural areas, the capacity of the storage really is less. The consumption is few than urban areas. These figures means that we are able to install a small size of the storage, because also in the building that DSOs are using and operating in the grid is not widely free space to install technology. In smart rural grid, we discovered that at least 20 kilowatts hour for each one secondary substation, we are able to create isolate electricity systems to work grid not connected. Also, we studied the parting figures was what is the behavior of the train when we are charging batteries from the electrical, the secondary substation is grid connected, and also when we have working in a dynamic microgrid. And the same, what is the criteria to strategic discharge when we are manage the battery management system when we are grid connected, and what is the trend with we need to deliver electricity from the battery when we have electrical failure. And also, it's very important, customers, rural customers also, they appreciate that it's more important to get electricity or not electricity, but avoiding to switch. Sometimes in a hour, I have electricity, I lose electricity, half hour again, I get the electricity. It's better to stay 2 hours without electricity. If it decide 7 farms with electricity. This is the departing point to analyze. And also, we are following the criteria of the recloser. After 3 attempts, if not able to supply electricity, we cancel and the area is of supply electricity. But right now, it's not, the situation is not happening. Okay, before Smart Rural Grid, remember this is a black and white electrical network, it's nothing important, but what is the new things using the same electrical infrastructure? We install automation, we install IDPR, we install storage, we install radio telecommunication, we install fiber optical link, we install power line communications in the same electrical infrastructure, and we establish connectivity between sensors, hardwired or using protocols. Also, we will need to introduce the next level. Automation is like a remote terminal unit. It's following commands from our SCADA systems, but introduce the local controller and transformer control for each one. Secondary substation, the master is the local controller sending commands for each one transformer controller. It's the new concept that to upgrade remote terminal unit, giving distributed intelligence for each one secondary substation. That means through the telecommunication network, the systems is working included if we lose the connectivity from our SCADA system. The system is taking self-decision. Also, it's needed to install local energy management system because it's very important if every 15 minutes upgrade the constraints, the loads, the consumption. This information through our SCADA is sending a global energy management system and exchanging information that every 15 minutes, what is the maximum capabilities to deliver and to supply electricity at the wall of the consumers. My colleague Ferran explained a little bit more of the telecom, but this is the message for this slide is in a rural area, we achieve full high-level complexity of telecommunication links. We have radio links, we have PLC links, we have the connectivity thanks to xarxes obertes de Catalunya till Granollers. But this is in rural areas. We have the capability to build a complex medium size of the capacity of a telecom system. Also, we can share with the users. We are working to share the capacity to give connectivity and the isolate farms. My colleague Volker explained a little bit the architecture, but this slide is explaining what is the flow, message flow between global energy management system or SCADA system, local energy management systems, local controller, and so on, and the transformer. This is the hierarchy that that information it's achieving in the smart rural grid area. Going to the outcomes. What is the first value? We realized that in a rural area, we are collecting a lot of data. And utilities are not understanding the capability to get and to take decision from data. This is the last month sample is real values collected from our SCADA, and it's focusing in the consumption side. This is the amount of the power in a month. Sharing in the last 2 weeks is real also values. What are we discover or what is our outcome regarding voltage? Without IDPR, without intelligence, without the control to manage the low voltage grid, the variability of the voltage goes 243, I don't know, till 219. And using IDPR, controlling reactive power, controlling balancing loads and harmonics, we stabilize the quality of the voltage that is more stable. Regarding reactive power, this is the variability without power electronics, but it's not using capacitors. It's reacting in real time. My colleague Daniel explained the difficulties to achieve that. And this value of the reactive, we achieved 0 value of the reactive. But it's very important to manage the reactive when we are working in alarm mode, because it's the way to ensure that the electrical protection is working, we will need to control the reactive power. Exploring a little bit more detail of this point, the summatory of each one powers. The scale is it's collecting the data more relevant values that we have 3 phases kilowatts for each one in the wall of the consumption. This is the variability from 2 weeks. And balancing loads, we achieve this red surface that you can realize that we reduce the surface of the power. That means its current is not going through the electrical network. That means we improve mainly the efficiency of the grid. Also, the outcomes, the figures is amount of each one secondary substation. Taking more detail, this graph explains the last, this week, is 2 weeks ago, 20 hours profiles from smart rural grid consumption. Is amount also is a summatory for each one secondary substation. You can realize this scale is not the traditional that in the morning a little bit a peak, in noon another, and afternoon is different. We have 5 o'clock, we have a peak. I think farmers working, milking cows, maybe. And noon, nobody is at home or eating, enjoying lunch in the countryside, and enjoying TV, of course. This is the real profile from first week of this May. We also install PV. This graph is the surplus of the electricity after their own consumption in the owners that they get the opportunity to install distributed generation. We can also in the same week, the maximum capacity arrive 12, noon, 1 o'clock. It's nothing extreme, depending the intensity of the sun. And in this point, analyzing the interconnection point, we can realize that we have consumption and we have delivered electricity to the grid. The demand response battery side is very interesting to analyze this graph, because this is the way that battery is delivering electricity to the grid through local energy management system after the Kister contribution in the project, and also included in the local energy management system from UPC engineers. The system realizes what is the maximum peaks of the consumption, and when achieved the maximum state of the charge, the battery is discharging to compensate this peak. That means this electricity is delivered in the most close point of the grid. That means less of losses. And this is the whole of the graph. We have the consumption, we have PV generation, we have the scale of the battery delivering, and we have the excedent. That means if we manage all the graph together, the consumption in this point of the microgrid connection, is microgrid grid connection, tends values close to 0. I think I was a little bit quickly, but this is our outcomes till now. At the end, we explain the conclusions and the projection of the project. Thank you.
So we are really running ahead of schedule, which is good. If you have questions, if you don't have questions, I hope that the lunch is ready. So please, Javier, should you... Let me say, I was explaining, Javier, during the last 3 years, we have been touring around Europe with Ramon, participating in many conferences, explaining all these things. And normally, at the lunchtime, Ramon cannot have lunch because he's surrounded by people. The waiter, I'm getting used to serve him the lunch because normally there are a lot of questions. I hope today also. So for Xavier or for Ramon, any question from your side? Is anything, or you really want to run to the lunch? Any question? So then I got, just in case. But meanwhile, you should start to think about something to ask. Xavier, nobody is asking about the price of the batteries. I cannot believe it.
We cannot talk about a certain figure of price, but we are more or less talking about 5,000 euro for the entering level is 4.2 kilowatts hour capacity for household storage, and will be something like that, around 5,000 euros on.
Okay, so we understand that 4.5 kilowatt, which is enough for a household normally, for covering the night consumptions. But also for the industrial ones, do you have prices, or this is something which is already in the market?
We are cooking all these figures, so we just have this entering figure. There is around 5,000. I'm talking also including the installation, and we have to take into account that our batteries are including the inverter. Okay.
So and then we have the issue of the second life batteries.
Yes.
You have to know that everybody in Europe is looking for second life batteries from Nissan Leaf because they say that the cells are really the more performance. I know people from around here that they wanted.
Can you get again the number for the cost?
It's 5,000 euros.
For
It's 4.2.
4.2
kilowatt hour. Yes, yes. I'm including here is the inverter is inside. The inverter is inside the battery system,
So I would
and also some installation works are included. But it's roughly 5,000 euros,
So roughly €1 per watt hour.
more or less. Yes.
Thank you. Xavier Ballvé from TTA. Just to steer the debate. So we can imagine some rural masias that they all have a lot of storage in the form of electrical vehicles and electrical appliances that have storage embedded into them, and renewable energy. So what is the value of having a distribution company in the area if you can just plug and play devices and they work?
Yeah.
Okay. So my question is to invite you to think of, or you probably are thinking already, on the new business model opportunities that this
We don't
change.
stop thinking about the future of the DSO. So Francesc Estabanell would like to know which is the future of the DSO. We are working on it. Maybe we are the ones financing the PV cells, or we are the ones controlling remotely and giving value, adding value by the systems created by the project, and providing then services. We understand, we think that the DSO of the future will be service provider, will be digital, service provider. And service providers of what? Of connectivity. So people will have more and more things that they would like to connect to the Internet of Things, but also to the network, to the electrical network. The electrical network is already there. I have to say, there's no more investments. It's already there. It's the best battery. It's the best system for managing. I mean, it's already there. So we really think that in the future, we will be service companies, not anymore utility, as it has been for 100 years. So we are really looking forward. There are a lot of experience, especially in the Nordic countries. And Nordic countries, they are always 3, 4, 5 years ahead of us. And we see them, first thing, pure DNOs, they are talking to customers. So not to meters, or they are really having a direct relation with someone that they call customer. And this is very important. It's not only conceptual, it's very important because your behavior is linked to your considerations. So for us, it's a question of research and try new things and develop. I was saying about the storage systems. Everybody in Europe is trying to look for second-hand batteries from Nissan, and nobody knows where the second-hand batteries are. And I know people from here that they discovered through the internet that in Stockholm there was one second-hand battery from a car who crashed. And they took a van and they went for holidays there, they took the battery and they came back to Spain to have a second-hand battery because it was until now impossible to know where they were storing such a thing. The batteries, the X-Storage, is made out of second-hand batteries, Second Life, or new ones?
Both. For sure, the batteries, they don't have the same performance if you take the old ones or the new ones. So we are both selling the old coming from the cars, the old ones, and we are selling also new ones or different objectives for different uses.
Yes? Okay. I'm new to this, okay? So I may ask some silly question, but there are a couple of concepts which really interest me in the presentation of Ramon Gallart. One was that you were about to build in some kind of internet of electricity, and in some other slides, I have seen something that it looked to me like you said an electricity router, as I guess as a parallel with an internet router. Is this some piece of hardware that you have especially developed? And if you can briefly explain on that. Thank you.
Yes, thank you. Talking about Internet of the Electricity is one way to explain a new criteria to manage electricity between consumption and generation. Power electronics, IDPR, is not a router like telecommunications because it's not working at real time. But we are identifying the consumption. We are identifying creating and insert a tag, each one consumption, each one production. And using the forecasting technology, we are able to manage the reaction of the grid. Because doesn't make sense if from a generation side of consumption side. We are analyzing the whole of the electrical grid to get and to take decisions. I mean, if we have variability of the storage, and in first case, we have enough capacity to deliver and improve the grid, getting it every 15 minutes, the system is reacting, deliver electricity that we storage from the last historical of the behavior. Of course, it's not like a router that we are having collisions of the message. It's the way to explain. Having a high scope of the conceptual capability of production and the consumption, what is the convergence to operate the grid? Of course, we are analyzing the skills, not introduce IP address for each one. We are not doing making a boosting in the 15 hertz frequency. It's the way to understand the evolution, the trend of the consumption and generation. Yes. We are logging with using set points and internal distributed memory, and of course, at the beginning we have a few samples, and 1 month ago we have a lot of samples, and the skill and the quality and the stability of the information is improving. That means we are self-learning, upgrading from a global energy management system. The system have a cognitive capacity to learn about the evolution. But of course, getting a lot of values, we improve the response of the grid in two ways: grid connected and island mode. Island mode is to achieve the same quality of service in the rural areas than urban, and grid connected to improve the efficiency of the grid.
All right, thank you.
It's Steve Noguer from Bassols, DSO and supplier. When we talk about these new technologies and these new capacities and Internet of Things, we should also talk about how the setting of prices is far format in the market. Because when we design a system that the customer will be active, then when you have a basis of the presetted prices, it's something that it's, in my mind, it's not working because you already know the prices. So when you work with the vehicle to the grid and you have a storage at home, you interact with the system with something that is already known, that is the price. And if at 6 o'clock it's 100 euros, at 9 o'clock in the morning is 70 euro, so it's something that it's not working. So the technology is beyond reality, and then something has to be developed in laws and marketing design.
So you should be more digital. No, look, here we have Bjørn Brendal, I don't know where, hey, there, in Norway. He's studying local markets. Lunchtime, Bjørn. He's working very hard on this defining local markets of energy, where all this paradigm changes, especially if we have in mind that there will be private agreements between users. So this is under the umbrella of an European project. This is unfeasible. So there's no regulation in Europe covering all this technology. We always say technology is never the issue, it's regulation. So technology is already there. This is part of a dream that will be a nightmare for the regulator. But when regulation will be ready, this technology is there. I insist, there's a lot of people working on the development of the local markets, and the key is there to solve all this management. Sorry. Yeah.
Good morning. This is Alex from Magnus Commodities. I've got a couple of questions. One, I think, is quite aligned with the previous question. And the other one, I don't think there's a right answer right now. But the big discussion about this is going beyond being sustainable or innovative. It's about cost efficiency as well. Talking about batteries of 5,000 euros of a household, it doesn't sound appealing for a domestic. That's a big thing. And obviously, the more this way of consumption, of participating, not consumption, but participating in the market, would modify the prices and the way it is configured. So how do you see? I know that the innovation and technology is moving the projects, but how do you see the prices evolving to make it more profitable? One thing that I don't see is the numbers. Okay, what's behind? What moves to someone going to buy batteries and more going into this model? The other thing is about how do you see the regulation moving? That's a big issue right now in that sense. The regulation is not fast enough to cope with these changes. How do you see it moving? Because obviously we have to face some the current grid costs, and how do you see this change?
So, yeah, please.
May I answer the first one? Regarding the first one, maybe 5,000 euro for a 4.2 kilowatts hour capacity doesn't sound appealing nowadays, but you are right, the technology is evolving. And what is interesting at this point is that we are working into lanes. The one concerning mobility, so we are making better cars, we are making better technology, and we are improving the technology inside those cars, inside those batteries. and that is helping those cars get a better value, a better perception of value, and apart from that, we are getting better technology also to apply in the household or industrial storage. So as long as we are able to improve that technology, and we are not the only ones working in that technology, we will be able to be cheaper. And regarding the second point, you were asking, I think that regulation is always behind the reality. And hopefully we'll see in the next future how it changes, because I think there's nothing, we cannot go back. So we are in this clear lane. The distributed generation is a fact, is something real. The PV is getting cheaper and cheaper every year. The renewables and the environment are asking us to give them some opportunities. So I think sooner or later we will get there.
In addition to Xavier, let me explain that, in my opinion, I have two questions. First of all, we know really what is the real cost of the electrical infrastructure to supply electricity nowadays. And we are talking and thinking in the same way that we are managing electricity until nowadays. But in my opinion, the cost of the electricity, I am thinking in the same way that people explain that the cost of the electricity, the kilowatt hour, in few years disappears. I mean, we will pay like telecommunication systems with capacity, not from the kilowatt hour going to the grid. Of course, technology is feasible. We are very close to use. We have the capability to install scattered technology and manage and not concentrate facilities. But the change, this disruptive change, arrive when society when society want to use, governance laws change. It's like internet. It's my point of view.
Concerning the price or the cost of all this technology, not the batteries specifically, I'm Thaddeus Müller from Stadtwerke Rosenheim. If you have been driving for Germany in the last years, you see that there's a PV cell in any roof. So it's the opposite. There's no roof without PV cell. So the distribution companies in Germany, they already have the issue. The injection is more than they can accept in their networks. So at a certain point, they have to stop injection from private households. So this is sustainable energy which is lost. And he made the calculation of the savings. So when putting one of these devices, we already know which will be the savings of a DSO, European DSO, so in infrastructure, in upgrading, and so on. So now we are on the other side. We have to look for an industrial production which covers a certain margin between the costs and the maximum price which is willing to pay a company. So we are in this moment. And so there were some more questions, yeah. Parlant tinc una?
Yep, thank you, David Esteban. One of the beauties of this project that I'm sure will become evident during the presentation this afternoon has been the ability to integrate by making a number of components interoperable between them in the project. So when you see the cabinet is composed of a number of subsystems which interoperate with each other. So this is, at the end, something which happens in energy nowadays. And when we talk about battery management systems, energy management systems, whatever, we are talking about subsystems that our experience has been that they will have to cooperate between themselves. So my question is, how do you see the adoption in these subsystems of open standards, interoperability, open protocols, allowing for a smooth interoperability and integration between all of them? I guess that you see that I'm referring to the the effect of don't even try to open up my cover. This is a black box. And it will be probably, I'm not sure whether it's going to be sufficient to provide an API or whatever. So if the final thing is going to be composed of a number of subsystems that will have to work together, how this is going to be offered? Because at the end, it will be probably one of the drivers of the adoption of this. It's not going to be just choose my product. It's an adoption which will go probably wider. How do you see that? Open standards, open protocols, interoperability.
Thank you. Thank you for the question. Yes, it's interesting question about the interoperability, open protocols, and so on. Of course, let me introduce a few messages. Nowadays, the first thing to achieve intelligence and to get the interoperability with a device is define the data model that we want to do it. Because it's the first key to develop and decide what is the telecom and standard we will need to apply. IDPR, telecom device, transformer controller, local energy management system, each one is developed following all standards. Following a common information model, following standards telecommunication standards, and the final integration and each one part of the subsystems is able to be used and operate in any one network using the open protocols, the standard protocols. That means IEC 104 protocol, 850 protocol, and so on. This is able. We are using Modbus. We are using so one of the standard protocol. We will need to introduce our profile. But of course, the technology is open to introduce and connect with any systems that is able to understand these protocols. But it's the first issue to achieve.
And talking about closed and open things, there's another, I will not use the name, manufacturer of cars and batteries, internationally known. They are selling black boxes. And that's why we moved from this brand to Nissan, because Nissan wants to do exactly the same. They have batteries, they have cars, they have batteries with wheels, and but they are in the open side. So they are in the bright side of the road. And it's possible to talk with them and to deal and to ask for changes and to upgrade things. So it's the same business, different model, and we feel much more comfortable with the Nissan model.
Carmen Jimeno from GEOD. I have more a comment than a question in relation to previous discussion and what you, Santi, said, and also you, Xavier. Yes, to say that I think that the transformation that we see in the energy system is clearly putting challenges into the distribution grid, which will suffer more constraints or congestion. And these problems, they have to be dealt at the local level by the distributors. And this is the reason why this idea of these local markets is starting to be developed. At European level, all the associations representing distributors, we are working together on this issue and, well, setting or trying to figure out how this should work. But also, again, a local market without local price signals will not work. So how to bring this local price signals at the local level is another issue to look into it. And of course, I agree, legislation is always lacking behind, but I think the so-called winter package or the clean energy package now from the Commission is setting the rules or the principles for the development of all these challenges that we are discussing today. Of course, it's at European level, so it's general principles, but once it's adopted, it will force member states to implement it and to develop legislation, and then we will see this flexibility in our energy markets and new actors and everything what we have been talking about. will take time, but will arrive.
Thank you. Xavier Vallvé. Just pushing things like it seems to be the idea. I have a question for Ramon, basically, or thinking. When you showed your data, one of the things that you showed was that the capacity was relatively small because of the impact of storage and self-generation. So when I saw those figures, also yesterday I went to buy a LED light for home. And they asked me, no, I asked, make sure it's 12 volts. And the guy said, no, don't worry, this goes from 8 to 30 volts. Plug it. So we are concerned about AC plus minus 7% for an appliance that is DC, and it will take a big range of voltage. So we are using technological standards of the 50s or the 60s when appliances would burn if you were, or you had the flicker. I went to buy a television. It has an adapter. It operates at 19 volts like a laptop. So I'm questioning these local rural mini-grids, will they still be AC? Does it make sense? Or they would be DC and then let the power electronics handle whatever interface you need, and then we don't have to worry so much about balancing the phases and so on. So it's just a question on, I'd like to know your views. Thank you.
Yes, thank you. Yes, you are right. It's an internal discussion what is better to use DC or AC. But if you remember, we would like to develop the project using the same infrastructure, still maintaining the same architecture to the DSO. Of course, the range of the voltage of the usage of the device, the electronic device, we have a wide range till 80 volts, from 80 volts till 400 volts, I don't know. This is not the problem. This situation, the range increase, the problem of the voltage disappears. But it's nothing relevant. But for sure, year by year, the way to get the consumption of the grid is increasing the number of the devices that they are using switching sources. This is the new concept to install, but it's a new consumption skill that electrical grid, in the global concept, we will need to upgrade. Comparing what is the waveform of the generation is a sinusoidal perfect wave. What is the cause that this sinusoidal wave it was not clear is the load. If the device change the scale of the consumptions, the form of wave we will need to change, and the electrical grid we will need to upgrading in this sense. For me, it's as a result of the scale of the consumptions. It's not relevant in this sense. DC, AC, it is depending on if we will need to build a new device, but how many things we are able to connect with a DC. We upgrade all the farm, all the houses, our internal network to operate in DC. If society at the end change, the electrical grid, of course, it changes. Like DSO change when society needs to change, wants to change. This is my point of view.
Thaddeus Müller. I'm one comment, one question. The DSOs in Germany are more and more responsible for several things, for reactive power, for integration renewables, and for system stability. So in the past, we can say that, yes, the big ones do all these things, and now this comes more and more responsibility to us. So we need here solutions. My question is, we see on the horizon more and more e-mobility comes to us and will be have to be integrated in the grids. So you have shown us the vehicle to grid, and also the energy, put the energy in the grid from the vehicle. So my question, do you calculate this in the battery capacity? And what is, and it is the benefit for the consumer, what relates to the cost to the battery?
I'm not sure I understood the question, but if I'm not wrong, you were asking about whether the battery capacity is produced or is produced thinking about its ability to give back energy to the grid. Nowadays, we have a 30 kilowatt-hour capacity in our Nissan Leaf that it is able to give back energy to the grid. And the point is that we are now working with B2G technology that is able to work till 10 kilowatts power. So at this point, the degradation of the battery, because all of us know that the ion lithium batteries, at least so far, are getting lower capacity as the time goes by. So the charging and discharging cycles are neglectable if we consider the power that is required for giving back energy to the grid. I'm not sure if I'm answering to your question with that.
So I think that the consumer wants to have 200 kilometers driving.
Yeah.
And now he gives the energy back to the grid,
Okay,
and now he have 100 kilometers.
Okay, understood. It's a question of making the right agreement. So if you study the driver profile of usage of the vehicle, most of us use our vehicles maybe at most 2 hours per day. So if you have this profile of usage, you can draw a profile of usage of the battery from the grid. So you maybe, without compromising the driver needs, you can give energy to the grid maybe during 10 or 12 hours every day. That's lots of power, that's lots of capacity also for the grid. So it's very big value. We will see later with the regulation, with the translation of the regulation coming from the winter packets, how this is implemented here locally and how what is the figure for that value now. But we think it's very, very big value.
So there was also, some of you know, in last February, at the end of February, we were with Geode to California, and we visited some utilities, and especially emitter from Siemens, and they have been studying the profiles of consumption of 8 million customers. And we all think that the normal profile is consumption in the morning, go home, afternoon, and this was only valid for 14% of the consumers. So last time we were talking with Nissan, they are figuring out which will be the profiles, and one of them is charging at the office and having the car fully loaded, almost fully loaded, at home. So in this case, of course, you can make use of 80% or 70% of the load of your battery for supplying your home at night, that easy. I mean, no more difficulties. But the question of the profiles, we have a lot of ideals or standards which are not really true. And then we come to data, and data must be analyzed. Data analytics will be the key for really deciding whether vehicle to grid or vehicle to home is possible, and we can make a business model out of it or not. Is data analytics. That's basic. The data of the meters and the consumptions. So any other? I think that we did. Oh, one more. Good. 2 minutes. Thank you. Villa.
I've got this is Esther Parra from TechForce, and I've got the impression that we are considering that in the future everyone will have a car, will own their own car. How, and on the other side, I'm also hearing that mobility is evolving towards sharing cars. So there will be companies owning the cars, and then the users only will use the car when they need it. Are you considering that, or how this combines?
This you can say because you're living in Barcelona City. If you would be living in La Garriga, then there's no question, the car will... No, but this is absolutely true. And they have the business model. They also have foreseen this. They will be able to sell you or a battery or a car. But managing electricity will be with stationary batteries or with mobility batteries. Things will take time. Things will evolve. Most of us were at a Rifkin's conference in Sant Cugat, where he gave a figure which was really amazing. Sharing a car which is shared avoids 15 purchases of a car. Times 15 is, I mean, if you would be in the car industry, you would think about this, not 2 times, 15 times. And really, there's a lot of people, number of people now, which is not having in mind to buy a car, just sharing it. So, but put it in one side, and then in the other, the deployment of renewables and the needs of batteries and so on. Which, when it's a battery, is a car, okay, perfect, you have 2 in 1. So it's an offer in the supermarket. Normally speaking, there's a solution which will be stationary and mobility battery, but battery, let's say, or batteries, because this has been a question of confusion during these years of our project. The batteries in smart rural grid are not in the houses, are in secondary substations, and only are there to get the signal. Something is happening, something is going on, make the system up again with the new conditions. As there are surplus, they can deliver to the houses and so on. So it's a different thing. But of course, the battery should be placed somewhere or in the network or in the houses. And as we are distributors, we would like to manage batteries, but the winter package is saying no, so we have to agree on it. And oh yes.
May I answer?
Of course, you're the one of the batteries.
Concerning the point about car sharing you were talking about, I wanted to say that of course we are aware that car sharing is one of the main trends we have to face right now, all the car manufacturers. No? Above all, we talked about 2 main trends that are electric mobility and also connectivity and autonomous drive, that I like to put them in the same package. Electric mobility, I talked already about electric mobility. We think is the sole solution for future mobility if we want to keep the planet as it is right now. Regarding connectivity and all the things regarding B2G, storage, and so, I think that connectivity will help people share cars, because it's the only way we have to make the life in our cities sustainable, and also will help those cars being key elements of this electric system also, because with connectivity and autonomous drive, we don't need people to make part of this process of putting this car charging at that point where the V2G system will allow this car giving back energy to the grid. So it will make it itself. So we are absolutely aware of that trends, and we try to work on all them in the more optimized way.
Hi, I'm Marta, and this is a question for all of the three of you. It's more regarding next steps, and one of the slides that talk about contracts between neighborhoods that sells and buy energy each one. The thing is, in an area where there is more people, I'm thinking more near the city, and that you not do a closed smart grid, but you can produce and consume your own consumption, self-consumption, or sell it. The transaction between the neighborhoods will be a high rate. And the way to track this transaction, and it's regarding also to be able to put a price signal and a history record of this transaction. Have you think about how this technology will be? I'm thinking about the famous name of blockchain, but I'm not sure it is really the meaning here. Also, something that I'm thinking of blockchain is that perhaps that you are doing PV or this renewable energy will also be used for certificados de origen, energy certification, and also everything related to CO2 certificates. What is your point of view on this next step, which is the economic, of course?
Yes. Thank you. It's interesting. Is the next step? I don't know. Blockchain is the final solution, in my opinion. Get importance in our society. But if you remember, we was talking about identifying consumption, generation, and so on. This is from our side in the project is concerning that is variables that we will need to manage. If we are identifying the capability of the production and the needs for that as a result of the forecasting system of the consumption, we can drive the energy through using our grid, because our level of the variability of the configuration in low voltage level, we are able to redrive the electricity. Following the electrical infrastructure, we will get less losses. Going again in the main of the meaning of your question, there are several variables that we will need to introduce in the equation. But we have a capability, we have the point of connection, we have the forecasting of the consumption. We will get, using analytics, we will get the outcome and to get the decision. This for me, is the most important thing, that understanding to achieve local markets. But of course, when law give the opportunity to apply. But the technology is new variables that we are able to introduce in the question. It is no problem to get.
Answered? Yeah, local markets, I insist. We have take the opportunity during lunch to ask someone which is working worldwide. Blockchain is the word that we are using these days, knowing or not knowing what's going to happen. As I explained someone, we are in another project also with some of the partners here. We are going to install a huge battery here in Granollers, in our site. We expect to have a Nissan battery, and where we will make it available for the neighbors for their excedence of electricity. So they will have an application in their mobile where they will know their account, and they will have to decide whether to do with this. We want to play with the aggregator. Otherwise, we will never learn what an aggregator is. And yesterday, we had the information that we start a new project, and this project is about blockchain and chatbots. We have to use the new words. So let me say that you merited for lunch. The only thing I have to say is that we are, DSO is in the ground, is in the Teatre Auditori. So we are with people, we are locals, and we get everything from the people which is around us. So we have, in fact, what we have is a debt with society that we pay as we can. Huh? Today, the organization who has prepared the catering, the cooks, most of the waiters, everybody, is an organization which is taking care with a variety of difficulties in life. Huh? So we try to support them, and we ask them to be the responsibles. We made a test. Huh? We were very satisfied, and I hope you will be also. Take your time for networking is the purpose, and in 1.5 hours, we'll be back here, and then this will be really technical, interesting. I hope that your questions, I will not understand your questions, I will not understand their explanations. I will be simply here for introducing people. So have a good time and a good meal.